Okay, so now that we have dealt with the different types of sets, let's deal with the operation of a set. Operation of a set. So operation of a set basically means how are we going to use it, okay, for calculation. So how are we going to use, you know, sets for calculation. So the first is the union of two sets or unification of two sets. So let's assume that there are two sets given A and B, okay, A and B. Now, union of a set means when we combine set A and set B. Okay, so when we combine the elements of both the set A and set B, we call that as union of a set. Okay, so it is denoted by A U B. Okay, A union B. So it is equal to X such that X is an element of A, or X is an element of B, or X is an element of both A and B. So it is denoted diagrammatically like this, to mean that we are adding both the elements of A and B. Okay, we are combining both the elements of A and B. Okay, so when we combine both the elements of A and B, we call that as union of a set. So let's take the example here. Let's say that two sets are given. One is set A and set B. So set A contains 1 2 3 4 and set B contains 5 6 7. So now if you were to find A union B, what would you do? You have to just combine it. So it would be A union B, which is equal to 1 2 3 4 5, which is set A union 5 6 7. Okay, so the union A union B will be combined of all of this 1 2 3 4 5 6 7. Now this is an example of a disjoint set, right? Both the sets do not contain any element which is similar. So sometimes it may not be just as it may not be like this. So let's take an example like this. So let's say that one set is given, set A is given as 1 2 3 4 and set B is given as 2 3 4 5 6. Now here we see that there's three elements. These first three elements are similar to each other, right? So how do we build the union of a set in this respect? Here it is a disjoint set, so you just have to write the elements given in these two sets. Now here, since we have a common element, what do? 1 2 3 4 5 6. So these two are found to be common. So common means they both share the same element. Okay, so what does it mean to have the same element? It means A and B share the same element, so you don't have to write twice. Okay, so you just have to write only once. So 1 2 3 4 5 6, because both these three numbers, both the sets share these three numbers. Okay, so for example, how do you explain that? If you were to explain that with a Venn diagram, you would probably explain like this. So let A be the set A, set this be the set A, and this be the set B. Now since there is something which is common between the two, how would you plot it? So since this three number 2 3 4 are common to both the set A and set B, this is where you have to write, because this portion represents the commonness between the two. So you will have to write the 1 here, 2 3 4, and then you'll have to write the 5 and 6 over here. But anyways, this now leads to the next topic, which is called as the intersection of two sets. So I hope you are clear with the union of a set. The union of a set means when you combine both the elements of the two sets, we call that as union of a set. Now intersection of two sets. Now intersection of two sets. So assuming that we are given two elements. Assuming that we are given two elements, let's take the same example. Let's intersection of two sets. Let's assume that we're given two sets, 1, 2 and 3, and B as 2 and 3 and 4 and 5. So now, what is the intersection of a set? The intersection of a set is denoted by this one. Now, what does this mean? The intersection of a set operation helps us to identify the common element. Okay, so we know that these two sets have two elements which is common, 2 and 3. Okay, so the intersection of a set will help us to identify that which is common to each other. Okay, so sorry, I think I'm using this wrong. Sorry, this is wrong. This is for union. Okay, now let's deal with the intersection of a set. Intersection of two sets. Okay, intersection of two sets. So what does it mean by intersection of two sets? Now let's assume that we are given two sets. Set A contains 1, 2, 3, and set B contains 1, 2, 3 and 4. Now this is a bad example. Let's say this is 5. Okay, 1, 2, 3, 5, 1, 2, 5, sorry. So let's call this as 5. So now intersection of a set identifies the common elements. Okay, so what are the common elements here? 1 and 2, right? So 1 and 2 are common elements. So how do you write it? A intersecting B means overlapping. So which elements overlaps each other? 1 and 2, right? In both the elements. So let's say 1, 2, 5 intersecting with 1, 2, 3, 4. So what are the elements that is intersecting? 1 and 2. So it will be 1 and 2. Okay, so this will be the answer. So how do you plot that? By using Venn diagram. So let's plot that using a Venn diagram. So intersection means when both the sets intersect each other with their common elements. So here 1 and 2 are common, so you'll have to write here 1 and 2. Got it? So this portion indicates the intersection of a set. Okay, so this portion indicates the intersection of a set. So this is what is intersection of a set. So intersection of a set means the elements which are common to both the sets. Okay, so we can see this portion is the intersection of a set. Okay, now the other the other type is in the operation of a set. We also have this called as the complement of a set. Now what is it called to be? What does it mean to be a complement of a set? Now, given set A and B, complement of a set is that which is outside of the set. Okay, so let's say that set A is this one. Okay, let's say set A is this one. Okay, let's take this now. So complement of a set. Complement of a set is the element which is other than the element of the set, given set. Okay, let's say that the universal set contains the element 1, 2, 3, 4, 5. But set A, there's only one set and it contains 1, 2 and 3. Got it? So the universe, since the universe is the totality of the element, and set A contains only this element, so the complement of set A is denoted by complement of set A is normally denoted by A complement or A dash. Got it? So A complement or A dash will be U minus A, or universe minus the given set. Okay, so the complement is actually the set. A complement of a set should mean all the elements which is not included here, okay, but in the universe, existing in the universe, okay, or the universal set. Okay, so what are the elements which are not included in set A? 4 and 5. So the complement of a set should contain this too. Okay, so it is like U minus A, so it is like 1 2 3 4 and 5 minus 1 2 and 3. So it is going to be, the complement of a set is the set, the elements which are not included in the set. So in this case, set A complement is going to be 4 and 5. Got it? So this is how we can represent a complement of a set. Okay, so how do we express that with a Venn diagram? Let's express that with a Venn diagram. Okay, so given this to be the universal set, let's call this as U, and this to be the set A, then A complement is all the elements which is not in set A. So A complement will be over here because this is set A. All the elements of set A is here, so the A complement has to be all the elements in this area. So this is going to be the set complement of set A. Okay, so all the elements outside of set A are called complement of a set. Okay, now another thing is the difference of two sets. Now difference of two sets means when you want to find the elements which are exactly in one set, we use this operation called difference of a set. Okay, so the difference of two sets A and B, to be denoted by A minus B, is the set of all those elements which belong to A but not to B. Symbolically, A minus B means all the elements that you want to find which are included only in A and not in B. We write like this. Or if you want to find all the elements which are exclusively in set B and not in set A, we write like this, B minus A. So diagrammatically it will look like this. So all the elements which are only in set A, if this is set A, if this is set B, then if you want to find the elements which are only in set A, you'll have to use the operation difference of a set, or difference of two sets, so which will A minus B. So this is A minus B, it will give you this area. Okay, and B minus A will give you this area. So all of B, see this is a common factor, so this is, in one way this is A and as well as this is B. So we don't want this area, we just want this area which is very exclusive of A. So when you minus B from A, you will get this area. When you minus A from B, you will get this area. So this is exclusively for B, this is exclusively for A. So this type of operation is called difference of two sets. Okay, so let's see an example here. So if set A contains 7, 8, 9, 10 and set B contains 6, 7, 10, 11, 12, what you have to do is you have to subtract B from A or A from B, whichever you are trying to find. So if you subtract B from A, let's take this example. If A is equal to, so we're trying to find A minus B, what is it? Question mark. So A is given as 7, 8, 9 and 10. B is given as 6 and 7 and 8. Let's just say 10 and 12 and 13, let's just say it. So here, if you were to find, therefore A minus B should give you only those elements which are exclusive for A. So what is it? So all the common elements of A and B should be subtracted. So 7 is also included in both. So in one way you can do like this, just strike it off, the common element. Yeah, so all of this 3, 7, 8 and 10 are included here, so you will strike that off, and the remaining is 9. So a minus will be only 9. How about b minus a? B minus a will be, let's just write it, b here, 6, 7, 8, 10, 12 and 13, minus a, 7, 8, 9 and 10. So now what you have to do is just have to strike it off and see what is the remaining element. So 7, 7, 8, 8, 9 is not included here, 10, 10. So what is the remaining? 6, 12, 13. So the best way is you can do like this. You know, during exam you can use a rough sheet and you can write it on the side. So b minus a will be this one. Therefore b minus a will be 6, 12 and 9. Now how would you plot this? Now if you were to plot it on a Venn diagram, or using a Venn diagram, it should be like this. Let's say that these are two sets, a and b. So when you say a minus b, you mean you are subtracting the common factor from a. Okay, so anything that is common between a and b is being subtracted, or anything that a contains of b is being subtracted. So what is subtracted? This one is subtracted, b, since this is b, so what is remaining is this one. So this will be a minus b. Okay, this portion, it will be a minus b. So this portion will be a minus b, and this portion, when you subtract this out, this will be b minus a. So okay, let's just write it. So actually this is b minus a. So this portion is going to be b minus a. Okay, just call it, you know, of course you cannot plot two at a time, but yeah, so this portion is called a minus b, this portion is called b minus a. Okay, all right, so that is to do with the yeah, so that is to do with the difference of two sets. So operation of two sets. One is the union of a set. When you combine all the elements of a and b, we call that as union of a set. Now intersection of two sets. When you have common element between a and b, we call that as intersection of a set. This is how we express with using a Venn diagram. Now complement of a set. Complement of a set means all the elements apart from the given set. Let's say a is the set and it has this element within this, you know, so all the elements which is not of set a will come under this, which is called as the complement of a set. So any set that is apart from set a, this one, all the elements in this shaded portion will be the complement of a set. A difference of two sets. Now when you want to find the exclusivity of a set, or the elements which are exclusive to a particular set, we use the difference. Okay, difference of two sets. So a minus b will give you the exclusive element of set a. This is set a, and b minus a will give you the exclusive element of set b. Okay, so this will be it. So that's it. So we shall deal with the laws of operation. Set, we can use set to, you know, do certain operations, calculations. So we shall learn that in the next class. Thank you.